reputation, I guess.
Reputation?
Yeah.
What?
Okay, so today this is line and surface integrals 4, I believe, yeah. So we are computing surface area, so the integral speaks for itself right there. You got a double integral over omega square root of the partial with respect to x squared plus the partial with respect to y squared plus 1 dx dy. So it's a double integral, so you only have to worry about should I do it in rectangular coordinates or should I do it in polar, right? So in fact, why don't we just do one of the problems for homework? Number 3 is the easiest one, so let's just do that one. And by the way, number 6 on the video, not the video, but when I did the solutions, the problem was kind of messed up, so I changed it. So whatever, if you're gonna watch the video, I guess it wouldn't be on there, so just look at the written solutions then, or number 6. Do you guys understand the surface we're talking about in number 6?
Yeah. Yes.
Okay, what is the equation? Okay, since people are watching here. Number 6, what is the equation of x squared plus y squared plus z squared minus 4z equals 0? It's a sphere. What's the center of the sphere? 0, 0, 2, right? Because you add 4 to both sides, radius 2. So it's gonna look like this. So that means here's the origin, here's the point 0, 0, 2, and the radius of the sphere is 2. Yeah? So the z-axis is going straight up like that. And then it says find the surface area of the cap cut by the cone 3x squared plus y squared equals z squared. So it's a quadrant cone going like this. So the cap that's cut off is this cap right here. What is the surface area of the cap? Yeah, so I don't know, if you didn't refresh your homework, you might want to refresh it because I didn't change it. Because on the video, when I was doing the problems, I couldn't figure out what the heck they were even talking about. So I had to change the problem to that. Okay, so again, how do you figure out what omega is? Well, if you smash this region down onto the xy plane, that's just like we normally figure out omega. Okay, but we're doing number, what did I say? We're going to do number 3. This is the easiest problem on the homework. Find the surface area of the part of the paraboloid z equal 1 minus x squared plus y squared that lies above or on the xy plane. So it's like this. We have a paraboloid, right? Upside down, reflected over the xy plane, and then shifted up 1 unit. So here's a paraboloid right there. So find the surface area of that. Okay, so we set up the integral, double integral, square root of, so what you have to do is take the partial with respect to x. So if you solve for z, what is the partial with respect to x? Negative 2x squared plus, then you take the partial with respect to y, negative 2y, and then you square it, plus 1 dy or dx dy, or dy dx. But then now you gotta kind of decide, should I do rectangular or should I do polar? Well, anytime you see the quantity x squared plus y squared, you should do polar, right? Yeah. Okay, so we're going to do it over polar. So integral. Now omega is what happens when you smash this down onto the xy plane. You're going to get that, right? Because that's the xy plane there. That's just a circle. So if you look at it from above, what are you going to see? A circle of radius 1, because if you set z equal to 0, right? Okay, so therefore, if you integrate with respect to r, so remember, this is equivalent to r dr d theta. If I integrate with respect to r first, r is going to go from 0 to 1, and theta is going to go 0 to 2 pi. And then over here, you got 4x squared plus 4y squared plus 1, which is like 4x squared plus y squared plus 1. So isn't that just the square root of 4r squared plus 1?
Yes.
And there you go. That's a way easier integral than if you tried to do it in rectangular. What technique should I use here? Trig substitution.
No.
Oh, you could, but again, trig substitution is like down the list, right? Again, we have to, oh, you know that secant to the fifth integral?
Yes.
It came up when I was doing the problem, so it's in this chapter. Last year I just put it on the test just to see if you guys. Anyway, so this test, you guys can use half a page of notes. One side only. Didn't we do that for one test?
Yeah.
Yeah, because there's a lot of formulas on this test. And the ones that you want to have on the list is going to come up in worksheets 5, 6, and 7. Okay, so let's actually compute this. So I should let u equal to 4r squared plus 1. So du is equal to 8r dr. I'm going to erase here. Erase this. So this integral, because the first integral becomes the integral of square root of u, and r dr is equal to 1/8 du, right? And now what are my new limits of integration? Remember, we're doing this integral first, yeah? Right. Yeah. Okay. So what are my new limits of integration? 1 to 5. Okay, so antiderivative is u to the 3/2 with a 2/3, but then we also got a 1/8 from 1 to 5. Factor out the constant, so what is that, 1/12? And then what do we got? 5 root 5 minus 1. Did I do that correctly? Okay, and then now you got to integrate this from 0 to 2 pi with respect to theta. But since there's no theta in it, you just multiply by 2 pi, right? So if you multiply by 2 pi, you get 2 pi over 12, 5 root 5 minus 1, which is pi over 6 times 5 root 5 minus 1. And that is the surface area of, why did I erase that? Yeah? The surface area of that paraboloid. So that's the easiest one we have on tonight's homework. The other ones will be a little more challenging, especially number 6. And then you got some easy omegas, like number 1, that's an easy omega to do. Okay, so this test, you're going to be doing a lot of integrals now. And I don't think there's any problems where you just set it up. You're going to have to set it up and compute it. So of course, if you don't set it up correctly, that's a double whammy right there. Yeah? All right. So the last 3 sections in this chapter, they're all like applications of physics. Like flux. You guys know what flux is? What?
Oh, is that
Like when a liquid passes through a surface. Like how quickly does it, like is it like, what do you call a liquid that goes through a surface easily? As opposed to a liquid that doesn't go through a surface easily, it's called viscous, right?
Oh.
What's the opposite of viscous?
I don't know.
Come on, you guys are AP Physics C. I had a D in physics. Another one is called curl. Curl, like how an object like tends to rotate. And then, you guys never heard these terms before in physics? How come the other years they said yeah? And the other one is like divergence.
Flux is like magnetic, electric.
Oh, so got magnetic and electric flux, but then what about just regular liquids? Or, wait, time out. What about the X-ray experiment? Shooting something through foil or something?
Yeah, that's right. But not like a liquid.
Okay, whatever.
What's a weird?
What about a coffee filter then? There you go. Well, you got the thing and the water goes through it, right, the filter, but it leaves the coffee grounds behind.
All the weird.
But then if you're pushing oil through it, it's gotta be different than if you're pushing like, what did I just say?
Water.
If you're sending water through it, it's gotta be different than if you're sending like oil through it or something, right? Maybe you guys are gonna have to go ask Doc, like, what is the meaning of